In this video, we're going to talk about a couple different varieties of imperfect competition. So we're going to talk about oligopoly, and then we're going to talk about monopolistic competition. Now within oligopoly, we're going to discuss several different models of oligopoly. So there will be a lot of information in this set of videos. So let's start by thinking about oligopoly. And the interesting thing about oligopoly is that you have just a few firms, and anytime you have a few firms, strategic interaction between those firms is going to be very important. So we're going to need to expand our idea of what we think about as an equilibrium. Let's talk about the other types of markets that we've discussed so far. So we started by talking about perfect competition, and remember that in perfect competition, the firms don't pay attention to what the other firms are doing. All you need to know as a perfectly competitive firm in order to maximize your profit is what the market price is, and you have no control over that. So you don't really care about what other firms are doing. In terms of monopoly, you don't care obviously about what other firms are doing because there are no other firms. So at this point, we haven't really talked about anything other than firm behavior where they don't need to worry about the other firms. But anytime there are just a few firms, then these firms are going to need to think very carefully about what the other firms are going to be doing. And there's going to be uncertainty about that. So in terms of how we're going to think about equilibrium with oligopoly, we're going to think about what we call Nash equilibrium. And this is probably something that you would have discussed in a principles of micro class. You probably, when you discussed oligopoly there, you would have discussed some game theory concepts. If you didn't, then you need to go back to review some of that. And I've got my video on principles oligopoly where you can go back and look at Nash equilibrium and think about why we need to consider strategic behavior between firms. Let's just briefly review what a Nash equilibrium is. Remember, a Nash equilibrium is an equilibrium, an outcome, where all of the players are satisfied with the option they chose given what the other players chose. So notice that Nash equilibrium doesn't have anything to do with whether or not it's a good outcome for the firms or a bad outcome for the firms. A Nash equilibrium can be a very bad outcome for the firms. What matters is, do the firms regret their strategy? Do they wish they had played a different strategy once they see what the other firms have done? Let's go through a quick example of that, and this will give us an opportunity to kind of review some game theory stuff. So let's think about two firms. Suppose we have two firms, and our two firms are going to be Coke and Pepsi competing against each other. Let's suppose that the two firms have two strategies, and those two strategies are going to be to either advertise or don't advertise. Advertise or don't. Now let's think about what our game matrix looks like. So remember, a game matrix, it's going to have two rows and two columns. We're going to be thinking here about simple games, two players typically. So let's put Coke over here and we'll put Pepsi up there. And we're going to divide this box into two columns and two rows. And the rows are going to correspond to the two strategies for Coke, and the columns are going to correspond to the two strategies for Pepsi. So let's suppose the first strategy for Coke is either advertise or don't advertise. Let's suppose that the first strategy for Pepsi, advertise, second one, don't advertise. So now this box right here would correspond to the outcome if Pepsi advertised and Coke advertised. This box would correspond to the outcome if neither advertised, and then these off-diagonal boxes would correspond to the outcome if one of them advertised and the other one didn't. Now we're going to divide these boxes, these cells, into two halves, and the top half up here is going to correspond to Pepsi's outcome in that cell, and the bottom half is going to correspond to Coke's outcome. Let's suppose that if both of them advertise, they earn 100 in profit, and we could make that 100,000, 100 million, it doesn't matter. Let's just leave it as 100. That's what they get if they both advertise. If they don't advertise, let's suppose they get 150. So the idea here is that the advertising doesn't get new customers for them. People typically don't start drinking soft drinks because of an advertisement. There are other things, what their parents drank or what their parents allowed them to drink when they were younger, things like that, that go into whether or not you're a soft drink drinker or not. So clearly the best outcome for these firms is if both of them didn't advertise. If they both advertise, they simply lose the money on advertisement and it doesn't get them new customers. The interesting outcomes are what happens if, say, Coke advertises but Pepsi doesn't. Let's suppose if Coke advertises and Pepsi doesn't, then Coke is going to steal some soft drink drinkers away from Pepsi. Let's suppose that in this outcome, Coke gets 200 in profit and Pepsi gets 50. On the other hand, this outcome down here would be the outcome if Pepsi chose to advertise but Coke didn't. And in that case, let's suppose it's Pepsi that gets the 200 in profit, and because they stole the customers away from Coke, Coke only gets 50 in profit. Now we've got a situation where we've got a classic prisoner's dilemma, right? And so the best outcome from the point of view of the firms is to not advertise. The problem for each firm is if each firm knows that the other firm's not going to advertise, it's in their best interest to go ahead and do it. And let's just verify that. We call that a dominant strategy, but let's verify what's going on. Let's suppose that let's take Pepsi's point of view. So we are now thinking about ourselves as if we are Pepsi. If Coke advertises, then we are going to be in this column, or excuse me, in this row. Our choice is to either advertise or not advertise, which means because we're in this row, we're either going to get this outcome of 100 or this outcome of 50. We would rather get the 100. So if Coke advertises, we should advertise. But Coke might not advertise. If Coke doesn't, if Coke chooses not to advertise, let's put here, if Coke doesn't advertise, then we're in this in this row. We can either advertise or not advertise. If Coke's not going to advertise, we're going to have either this outcome of 200 or this outcome of 150. And so if Coke doesn't advertise, we would rather have the 200, which means we should advertise. If Coke's not going to advertise, then we can steal some of their customers by going ahead and doing that. We should advertise. What we see here is that regardless of what Coke does, we should always advertise. Pepsi has a dominant strategy of advertising. We could do the same thing if we took Coke's point of view. We could think about the two options that Pepsi has and what we should do in response to that. And what you'll see is that Coke has a dominant strategy to advertise. So the likely outcome of this game is right there, where both of them advertise, both of them end up wasting the money on advertisement, and there's a better outcome for both of them if they were to cooperate with each other and not advertise. But the problem is that there's this strategic interaction. If you know what the other firm is going to do, if you've come to some agreement, you can exploit that and you can come out better if you break the agreement. Now, let's verify that this outcome right here is a Nash equilibrium. This is what we're after. So, if we're in this outcome, that means that both players advertise. Let's take the point of view of Pepsi again. Let's think about whether or not we regret our strategy of advertising. What we've just realized is that Coke advertised. We also advertised. Do we regret advertising? Well, if we hadn't advertised, then we would have ended up with only 50. So clearly we don't regret our strategy. If we had played a different strategy, we'd be even worse off than we are now. Let's take the point of view of Coke. So we're Coke, we chose to advertise, and we observed that Pepsi also chose to advertise. We could have not advertised, and if we hadn't, we would end up with 50 instead of the 100 that we got. So Coke doesn't regret its strategy either. Neither player regrets their strategy. So this outcome, of course, is a Nash equilibrium, and I would challenge you, what you should do is go ahead and verify that these other three outcomes are not Nash equilibria. If we were in that outcome right down here, where both of them had chosen not to advertise, then both of them would regret their strategy. If we are Coke and we observed that Pepsi didn't advertise and we got this outcome, we could have done better than that. We could have gotten 200 by advertising when they didn't. We would regret our strategy, and Pepsi would regret their strategy. We would see the same thing in these. So this outcome is a Nash equilibria, but from the point of view of the firms, if they were acting as a team, that's not a good outcome for them. So hopefully that gives you kind of a refresher on the importance of strategic interaction and studying a Nash equilibria rather than the other types of equilibria that we've thought about with perfect competition and monopoly that didn't involve any type of strategic interaction. So now let's start to think about different models of oligopoly, and there are several of them that we're going to think about. The first type of model is we're going to think about oligopoly with identical goods. The goods in an oligopoly don't have to be identical, but we're going to start there. Oligopoly with identical goods. So let's think about the characteristics of this type of oligopoly. What we've done with our other two market types, perfect competition and monopoly, is we started by thinking about the characteristics. So here, clearly the first characteristic of an oligopoly is few firms. We're typically going to be thinking about two firms, which we call a duopoly, but a duopoly is just a particular type of oligopoly. We're going to be thinking about identical products, so the firms, what they're making, that it's identical between the firms, so identical goods. And then we're going to think about the outcome if firms agree to collude and no firms break the agreement. So firms agree to collude and they stick to the agreement. In a principles class, you would have talked about the conditions under which cooperation is actually more likely. Those are things like if it's a repeated game, or if the firms have the ability to punish each other, or if they have a history of participating in the market together. Those are all situations where there's a higher probability of colluding. So that's where we're going to start. Let's think about, and the idea here is that the firms are forming a cartel. So this is a cartel. Now, the agreement has to be secret because this is illegal. We'll talk about that here in just a second. So this outcome is easy with this type of oligopoly where there are few firms, the goods are identical, and the firms are all colluding. This is the exact same as monopoly. Same outcome as monopoly. So we already know how that works. It's the same outcome as monopoly. We would look at the market demand curve. We would come up with the marginal revenue curve, set marginal revenue equal to marginal cost, and then once we figured out the quantity, we would get the price from the market demand curve. So mathematically, theoretically, everything with this type of oligopoly is exactly what we did with monopoly. So the firm is going to produce the quantity where marginal revenue equals marginal cost, and then the price comes from the market demand curve. Market demand. So what the firms would do is they would just split the market up. If there were two firms and the quantity that they would produce as a monopoly is 100 units, they would just divide that in half, each produce 50, and then they would charge whatever the market price is for 100 units. They would both charge that price. Let's think about the instability of collusion, though. So why is this relatively unlikely? Instability of collusion. People have a tendency to believe that there's more collusion out there in the world than there probably is. There is some. Sometimes firms collude with each other against the public. But there's not as much as it appears to be. So we'll talk about that a little bit later, but let's think about why collusion is actually relatively unlikely. Let's do this by thinking about a particular example. So let's suppose we have an example where the market demand curve looks like this. P equals 14 minus Q. That's a market inverse demand curve. Let's have a nice simple marginal cost curve. Let's suppose marginal cost is equal to 2. We're going to be assuming here that fixed cost is equal to 0. That means our marginal cost and our average total cost are equal to each other. So this assumption means that marginal cost and average total cost are equal. And if you want to verify that, just come up with a cost curve that has no fixed cost, and then calculate both marginal cost and average total cost. And you'll see that they will be equal to each other because fixed cost is equal to 0. We need to come up with our marginal revenue curve because we need to set marginal revenue equal to marginal cost. We're working with the inverse demand curve, so we don't need to invert anything. That's what we want to be working with to get the marginal revenue curve. So our marginal revenue is going to be, marginal revenue is equal to 14 minus 2Q. Same intercept, twice the slope. Now we're going to set marginal revenue equal to marginal cost. So 14 minus 2Q is equal to 2. That gives us 12 equal to 2Q, and Q is equal to 6. Now if we take that quantity and we plug it back into our inverse market demand curve, we will get P equals 14 minus 6, so the price is equal to $8. What this means is that each firm is going to produce 3 units. We're going to assume that the firms just divide the quantity in half. They're each producing 3 units, so each firm produces 3. They're going to charge $8 for every unit. And so their profit, let's figure out what their profit is going to be. Profit is going to be the price minus the average total cost, which is 2. So it's going to be 8 minus 2 multiplied by the quantity that they are producing. What we've got right here, this is just, let's put it right in here. Profit, now let's put it right down here. Profit is equal to price minus average total cost multiplied by Q. That's all I'm doing right there. And I'm taking advantage of this assumption that we've made where fixed cost is equal to 0. So what we've got here is 6 times 3. Each of them is going to earn a profit of $18. Total profit, so this is profit for each of the firms. Total profit would then, of course, be $36. Total profit is equal to 36. Now let's draw a picture of what we've done here. It's always useful to think about what we've done here in terms, once you've done the math, it's useful to think about what you've just solved for graphically. So we've got quantity, we've got price here, we've got a demand curve, an inverse demand curve that is solved for P, so we can graph it in this space. Our intercept is 14. It's got a slope of -1, so it comes down there like that. We've got a marginal revenue curve with the same intercept and twice the slope, so it comes down here like this. There's marginal revenue. Our marginal cost is constant at $2, so there's 2. Marginal cost looks like that. We set marginal revenue and marginal cost equal to find that intersection, and out of that came the quantity 6 units. And then we plugged that quantity of 6 units back into our market demand curve, and that takes us right back up here. We got a price of $8. So that's what we've done. And then we calculated profit, which you can see total profit is this area right there. This vertical distance is 6 times this horizontal distance, which is 6. We got a profit of $36. So everything fits here. That's the collusive outcome. That's if they're going to agree to collude and then stick to the agreement. But let's talk about how unstable that outcome is. Let's suppose we consider firm A's point of view. Firm A can reason this way. And we're doing essentially the same thing that we did over here when we figured out what the dominant strategy is for Pepsi, and then we thought about it for Coke. So firm A can reason this way. We can produce 3 and get a profit of $18. That's the agreement. Or we can break the agreement and actually produce 4 units. Or we can produce 4. And that will get firm A more profit. Now, they're not going to call firm B up and say, hey, guess what, we're doing this. They need for firm B to be producing 3 units. They're going to break the agreement secretly and show up with 4 units. Now, let's talk about what ends up happening in the market. So the total quantity now is going to be the 3 units that firm B produces and the 4 units that firm A is going to bring. Okay? So the total quantity will end up being equal to 7. We can plug that into here, into the market demand curve, inverse demand curve, to get what the price is. 14 minus 7 is equal to 7. So price will fall to 7. But now let's figure out what profit for firm A is. Profit for firm A is the price, which is 7, minus average total cost, which is 2, multiplied by the quantity that it brings. And firm A is now bringing 4. So this is 5 times 4, which is $20. That's a better outcome than if they just brought 3. But now let's see where that extra profit comes from. Let's calculate profit for firm B. Firm B brought 3 units. Now the price is still driven down to 7, so for firm B it's going to be 7 minus their average total cost, which is 2, multiplied by the number of units that they brought, which is 3, and they're going to end up with profit of 5 times 3, which is $15. Essentially, by breaking the agreement, firm A is able to take some market share away from firm B, just like what we saw here. Notice that the total profit falls to $36. Total profit, $35. It falls to $35, which is a worse outcome in terms of total profit than if they had stuck to the agreement. So you can see that this is a different version of exactly this. This is the prisoner's dilemma. We're just analyzing it a little bit differently. So both firms are going to face the same incentive. Both firms are going to face an incentive to produce 4. So what we would actually see, the likely outcome, is probably that both of them break the agreement and produce 4. That means the total quantity in the market is going to be 8. That drives price down another $1 to 6. And what you'll see is that they end up with a likely outcome where they're even worse off than these two outcomes. And you can verify that. It's very easy to figure out what their profit is going to be if they both break the agreement and bring 4. It's also the case that increasing the number of firms in the cartel causes the collusive outcome to be even more unstable. So if we were to increase the number of firms to 3 units, or to 3 firms, where each firm is producing only 2 units, then if you go through that, and I believe your book does go through an example where they do exactly that, you'll see that there's an even stronger incentive to break the agreement. Here, the incentive to break the agreement is that you can get a couple of extra dollars of profit. You can get 20 instead of 18. If we have 3 firms, each producing 2, and then you see what would happen if one of those firms brought a 3rd unit, you'll see that there's an even stronger incentive to bring that 3rd unit. So let's clear this off and then let's review. I mentioned a couple of them, but let's review the conditions under which collusion is more likely. So I'll clear this off and then we'll take a look at that. In terms of the conditions under which we would expect a higher probability of observing collusion, one of the obvious situations is if the 2 firms could punish each other. What makes that tricky is that the punishment clearly can't be in the form of a legally binding contract because collusion is illegal. So they can't sign a contract to collude. There would have to be some other way that they could punish each other, and that could be, maybe they could. It could be threats of physical violence. There are plenty of examples where firms have colluded, and that's one of the things that held the collusive agreement together. Or it could be one firm punishing the other firm economically. There's some evidence that there are times when one firm might flood a market, put so much of a good on the market that it drives the price down to the point where it hurts the other firm. The problem with that is flooding the market also hurts the firm that's flooding the market. So the firm doing the flooding has to somehow be able to withstand the economic hardship that they are trying to create for the other firm, which also impacts them. So let's just leave it at if the firms can punish each other, there's a higher probability of colluding. If they both face the same marginal cost curve, then it's going to be easy for them to split the profits. So what we did was we assumed that there was a total quantity of 6, and then they split that down the middle and produced each 3. Well, the firms could bicker with each other about one firm producing more, maybe that firm's been around longer, or if there is a firm with higher marginal cost, then they're going to argue that they should be able to produce a different quantity, and so that can create a situation where collusion is less likely because they bicker with each other. But if the marginal costs are equal to each other, then it's going to be easier to come to that collusive agreement. If it's a repeated game, So if these are firms that have been in the market for a long time and expect to be in the market for a long time, then there's going to be a stronger incentive for them to go ahead and forego current profits because they know that that increases their long-run profits. It's one thing to earn a quick buck today, and there's an incentive to do that. But if you can resist that urge and know that you're going to be better off in the long run if you don't break the agreement, then that will increase the probability of actually being able to collude with each other. If there's a small number of firms, then there's a higher probability of colluding. The larger the number of firms, the stronger the incentive to break the agreement. And remember that all it takes is for one firm to break the agreement, and then the whole collusive agreement breaks down. So the more firms there are, the harder it is to maintain collusion. And then if they have a relationship, so if the firms are owned by owners that know each other or are friendly, or maybe they've had some other relationship, business relationship in a different context, and so they know that they can trust each other and they know that the other person's not going to break the agreement, then there's a much higher probability that we would observe collusion. So we do observe some collusion. There are some excellent examples out there where we know firms have been prosecuted for collusion in the airline industry, in the international chemical industry. There's cases where firms have colluded. Clearly, OPEC is a cartel. That's a collusive agreement between countries in the Middle East. There's the Mexican drug cartel, which is a collusive agreement between different groups that are selling drugs. So there are lots of examples where cartels have been very successful. Let's think about another type of oligopoly model, and that's what we're going to call Bertrand competition. Bertrand competition. Let's think about the characteristics of this. The first one of all of these is that there are few firms. Here, the firms will sell identical goods. Again, identical goods. The firms in this particular situation are going to compete by choosing price. So they compete based on price. Compete by choosing price. And we're going to have the firms pick their price simultaneously. Firms pick price simultaneously. So they don't get to pick their price early and then reveal that to the other firm. They both have to pick their price, and then they release their price, and that's when they get to see what the other firm did. So let's work through how this would work. Let's think about a situation where there are two companies, two firms. In this case, the customers are going to buy from whichever firm has the lowest price because the goods are identical. If the goods weren't identical, then we'll see something a little bit different. We'll do that here in just a little bit. But with identical goods, the firms are going to choose, or the consumers are going to choose to buy from whichever firm has the lowest price. If both stores have the same price, let's suppose that they just split the market down the middle. So they each get half the demand for the good. So here's what demand looks like. Demand is going to look a little different than what you're used to, but don't worry about that. So demand, let's say demand for the good at firm A, let's say from firm A, is going to look like this. It's going to be the full quantity if firm A's price is less than firm B's price. If firm A chooses a lower price than firm B, then they're going to sell all of the quantity that consumers want to buy. It's going to be half the total quantity if firm A's price and firm B's price are equal to each other. So if they both choose the same price, they split the market. And then firm A will sell nothing if firm A's price is greater than firm B's price. So we get this kind of odd demand situation. We're also here assuming that quantity doesn't depend on price. And that's really just a simplifying assumption, so don't worry too much about that at all. Demand for B from firm B would look very similar. They will sell all of the quantity. If firm B's price is less than firm A, they'll sell half of it if they have the same prices, and they'll sell nothing if firm B has a higher price than firm A. Let's suppose that marginal cost is equal to, let's make it 100. And let's suppose each firm starts by charging a price of $150. Each firm charges $150. We need to start someplace, so let's just start there. Now let's think about what each firm has an incentive to do. Let's take the point of view of firm A. There are lots of different strategies here. They can choose any price they want, but let's just kind of think dynamically about what's going to happen. If I'm firm A and I think firm B is going to charge $150, then what I need to do is just charge a little bit less than that. If I charge $140, then I will sell all of the quantity that consumers want to buy, and the other firm is going to sell nothing. But if the other firm observes that I charge $140 and then the next day they think to themselves, you know what, we can do better than that, we'll charge $130, then they're going to sell everything. But then I can undercut $130, I could charge $120. So hopefully what you see is that both firms are going to have an incentive to undercut the other firm's price until price gets driven right down to there. So each firm has an incentive to undercut. Let's say it this way. Each firm has an incentive to lower price until price ends up being equal to marginal cost, which, of course, is the perfect competition outcome. So we've got a situation here where the price will be driven to equal $100. Profit for each firm will be equal to 0. This is the same outcome as perfect competition. Notice that we get the same outcome as perfect competition with just two firms in the market. It's tempting sometimes to think, at least in a principles class, what you tend to observe is that profit gets driven to 0 when the number of firms is really big, when there's free entry. So if you think back to the different types of firms, let me kind of squeeze in up here the types of firms that you talk about in perfect competition or in a principles class, and the same types that we're talking about here. We talk about perfect competition, profit gets driven to 0. We talk about monopoly. Profit ends up being positive as long as the firm is selling something that consumers want to buy. A lot of times in a principles class you talk about oligopoly, but we don't really go into much of it with a principles class, and usually what we do observe is that profit ends up being positive with oligopoly because there are barriers to entry. And then we talk about monopolistic competition. And with monopolistic competition, profit ends up being driven to 0 because there's free entry. So it's tempting, if you walked away from a principles class, it's tempting to think that the thing that determines whether or not profit is equal to 0 is just whether or not there's free entry. If there's free entry, profit's going to get driven to 0. Whether the goods are identical or whether the goods are differentiated. Now what we're seeing is there can be barriers to entry. There can be only two firms in the market, and there are times when profit will be driven to zero. If the goods are identical, and if the firms are competing with each other based on price, then we're typically going to be observing the same outcome, profit being equal to zero, price being equal to marginal cost. That's what we observe right down here, at least right there. So we get the same outcome as perfect competition. Same outcome if the number of firms is increased. So if we had 3 firms producing identical goods, competing with each other on price, profit will get driven to zero, price will get driven to equal marginal cost. Let's talk about something that falls in between the two here. So we've discussed the collusive outcome. That's the same as monopoly. We've talked about Bertrand competition. That's the same as perfect competition, same outcome. Now we're going to talk about a different type of oligopoly that's known as Cournot competition. Cournot competition. Let's start, like we always do, by thinking about the characteristics. The first one, we're in oligopoly here, so there are a few firms. The next one is that firms sell identical products. Firms sell identical goods. Now the firms are going to compete by choosing quantity. Firms compete by choosing quantity. All goods are going to sell for the same price. So the firm doesn't choose price now, they're going to choose quantity. And the firms are going to choose their quantity simultaneously. Firms choose simultaneously. So this is a little bit different than our Bertrand competition. So you might ask, well, when would we see something like this? Well, we tend to see something like this. It's common if there are firms that have capacity constraints. So in terms of how much output they can produce. So it's going to be more important for them to choose the quantity that they can produce because they're not going to end up having any control over the price. The price is determined in the market, and they instead focus on choosing the right quantity for them. So let's do the same thing. Let's suppose that we have 2 firms. Let's make things simple. Let me put a little line here so we can set this apart. 2 firms, let's suppose that they have constant marginal cost. Suppose constant marginal cost. And we can think about a demand curve that they face. What your book does is your book starts by thinking about a general example of this. They give you a demand curve, and I'll give you one here in just a second, and a marginal cost curve where they don't put numbers to it. And what I've found is that it's okay to work through that, but a lot of times students are much more comfortable if you just give a demand curve and a marginal cost curve that have some numbers, and so we'll do that. So when you see this at first, don't start to think, oh, this is going to be really different from what we've done. It's not. But let's suppose that our marginal cost is just constant at C. That's just some number, like 100. Okay, something like that. And let's suppose that we have an inverse demand curve that looks like this. P equals A minus B times Q. Now the total quantity, this is the market demand curve, inverse demand curve. The total quantity that's sold in the market is going to be made up of how much firm 1 produces and how much firm 2 produces. So the total quantity, Q, we're going to write as little q1 plus little q2. How much firm 1 produces plus how much firm 2 produces. So we can think about the profit for firm 1 and the profit for firm 2. If we think about profit, it's going to be price minus average total cost, and let's make the same assumption that our fixed cost is equal to 0, so our average total cost ends up being just equal to C. So it's going to be price minus P minus C multiplied by however much firm 1 produces. That will be the profit for firm 1. And the profit for firm 2 will be P, price minus average total cost, times however much firm 2 produces. Okay. So now, let's plug in a couple of things here. This means that profit for firm 1, I can plug in right here what price is. This price is equal to A minus B times Q. And this quantity is equal to Q1 plus Q2. So let me write this out, and it's going to look just a little bit complicated at first. Once we put numbers to it, it will seem much less complicated. Okay, so bear with me for just a second. I'm going to move my Q1 to the front right here. So this is Q1 multiplied by A minus B times Q1 plus Q2. That's what profit looks like. Actually, I have to subtract off my C here, so ignore that little paragraph or parenthesis, minus C. I've got to have my P minus C. I forgot that. And again, that looks complicated, but don't be deceived by that, because once we give numbers, make A a number and B a number and C a number, this is going to be much easier to deal with. Likewise, profit for firm 2 will look like this. However much quantity firm 2 sells multiplied by A minus B times Q1 plus Q2 minus C. There's what profit for firm 2 looks like. Here's the important thing. Here's why we've done this at this point. What we see is that the profit for firm 1 is a function not just of the quantity that they produce, but also the quantity that firm 2 produces. So firm 1's profit maximization problem is very challenging. It depends not just on what they do, but what the other firm does. And this is just another way of seeing something that we've seen in all of these models that we've looked at so far. Same for firm 2. Profit for firm 2 is a function not just of the quantity that they choose, Q2, but also the quantity that firm 1 produces, Q1. If you want a good example of this type of market, the oil market is an excellent example. Crude oil market. So OPEC, those countries don't choose the price. What those countries choose is they choose the quantity of oil that they are going to supply to the market. They choose production amounts rather than the world price of oil. Now, the world price of oil clearly is a function of the quantity that all of the firms produce. So let's do now an example here where we have some numbers, and you'll see this is very easy. So let's suppose we start with a market demand curve that looks like this. Suppose we have P equals 300 minus 5Q. Nice simple market demand curve. Clearly it's an inverse demand curve. Let's go ahead and plug in. Remember that big Q is equal to little q1 plus little q2. So the market demand curve actually looks like this. 300 minus 5q1 minus 5q2. There's the market inverse demand curve with two firms. And let's make our marginal cost constant at $30. Fixed cost equal to 0, so that's also equal to average total cost. Now, let's figure out what the marginal revenue for each firm looks like. So each firm is still going to choose its quantity by looking where marginal revenue and marginal cost are equal to 0. Now, we know how to get the marginal revenue curve when there's just one firm. It's got the same intercept and twice the slope. Now there are two firms, but getting the marginal revenue curve for each firm is actually very straightforward. Here's what it looks like. Marginal revenue for firm 1. You take the same intercept, 300, and then you double the slope that corresponds to that firm. It's going to be minus 10Q1, but you leave the slope that corresponds to the other firm alone, minus 5Q2. There's marginal revenue for firm 1. So it's got the same intercept, and in terms of firm 1's quantity, it's got twice the slope, but we leave this other term alone. Okay? Now, let's focus on firm 1. Let's set marginal revenue for firm 1 equal to its marginal cost. So we've got 300 minus 10Q1 minus 5Q2 equal to 30. It's marginal cost. And now what we want to do is solve for Q1. We want to solve for the quantity that firm 1 is going to produce. So solve for Q1. If we do that, I'm going to move my Q1 to one side by itself. So this is going to be 270 minus 5Q2 is equal to 10Q1. So I grouped these numbers and then I moved my Q1 to the other side. I'm going to just flip this whole thing around. I'm going to write it this way. 10Q1 is equal to 270 minus 5Q2. I like to have what I'm solving for on the left. And I'm going to divide, that should be 270. I'm going to divide through by 10. So Q1 is equal to 270 divided by 10 is just 27 minus 5 divided by 10. That gives me a 2 in the denominator. Q2 over 2. We've just solved for the quantity that firm 1 is going to produce. But notice that it's not just a number. The quantity that firm 1 is going to produce depends upon the quantity that firm 2 produces. And firm 1 doesn't know that quantity. We've got a name for this. We call this a best response function. Best response function. Also known as a best reply function. So also known as best reply function. And I kind of use those terms interchangeably. There's actually a third, if you've had depending upon what principles of micro textbook you used, or if you've had a game theory class, you might even call it a reaction function. All of those mean the same thing. Basically, it tells us what firm's best reaction is given firm 2's quantity. How should firm 1 react to what firm 2 does? Okay. If you do this same process for firm 2, and I would encourage you to do that, you'll see something really nice. If you assume that firm 2 also has a marginal cost of $30 and the marginal revenue for firm 2 is going to look like this, it's going to be the same intercept. We leave the part that has to do with the other firm alone, so minus 5Q1, and then double the part that has to do with firm 2, double the slope, minus 10Q2. There's the marginal revenue curve for firm 2. Set that equal to marginal cost. You will get something that looks just like this. Q2 is equal to 27 minus Q1 over 2. That is firm 2's best response function, reaction function to what firm 1 does. So now we have a function that describes how each firm should optimally react to the other firm in order to maximize its profit. By setting marginal revenue equal to marginal cost, we are making these firms, we are assuming that they're maximizing their profit. So what we've got here is we've got two equations and two unknowns. We need to know what Q1 is and we need to know what Q2 is. Anytime you've got two equations and two unknowns, typically, there are some mathematical restrictions on that, but if you've got the same number of functions as you've got unknowns, then you can solve that system of equations. So what I need to do is clear this off and then we'll solve that and see what it looks like. Let's write our two response functions that we've got here. So we've got Q1 is equal to 27 minus Q2 over 2, and Q2 is equal to 27 minus Q1 over 2. Those are our reaction functions or best response functions. Two equations and two unknowns. I'm going to, let's solve for Q1. Let's solve for Q1 by taking this function for Q2, this thing, and plugging it in right there. So I'm going to write the first function. Q1 is equal to 27 minus 1/2 multiplied by Q2, which is 27 minus Q1 over 2. So I'm just substituting, if we were to call that equation 1 and this equation 2, I'm just substituting equation 2 into equation 1. Okay. What we're going to get there, that should be 27. What we get is Q1 is equal to 27 minus 27 over 2 plus Q1 over 4. So 27 minus half of 27 is equal to 27 over 2. And I'm going to subtract this thing from the other side. I get Q1 minus Q1 over 4. So I can make common denominator here. So I have 4Q1 minus 1Q1. That gives me 3Q1 over 4 equal to 27 over 2. And then I need to get rid of the 3 and the 4. So if I do that, I'm going to multiply both sides by 4/3. It'll cancel out over here. So I'm going to get Q1 is equal to 27 over 2 times 4 over 3. That's 1, 2. This is 1 and 9. That gives me 9 times 2. That's 18. Q1 is equal to 18. So given these best response functions, Q1 is going to produce 18 units. Now we can easily figure out what Q2 is going to do because we can take this quantity for Q1 of 18 and plug it right into here. So this gives us Q2 equal to 27 minus Q1, which we just solved for as 18, divided by 2. So that's equal to 27 minus 9. That's equal to 18. Q2 should produce 18. Notice that these best response functions are symmetrical. So shouldn't surprise us that we get the same quantity of output for each of the firms. So the total quantity is 36. Total quantity equals 36. We can figure out what the price is going to be by plugging that into our inverse demand curve. Remember, our inverse demand curve looked like this. P equals 300 minus 5Q. Q, the total quantity right here, which is Q1 plus Q2, is 36. So we get the price being equal to 300 minus 5 times 36. If you work that out, you're going to get that price is equal to 120. And then we can figure out what profit looks like. So profit for each of the firms Let's just do it in general, but it'll be the same for firm 1 as it is for firm 2. Profit is equal to price minus average total cost. Our price is 120 minus our average total cost, which is equal to our marginal cost, and that was equal to 30, multiplied by however much the firm is producing, which is 18 units. If you multiply that out, you'll get profit equal to $1,620 for each firm. Total profit would be 2 times that. So you can see that mathematically this feels like a very complicated process. I'm going to give you a very quick way of getting the two reaction functions, or the best response functions. It's actually very easy to get those if we assume a nice simple inverse demand curve. So we'll do that here in a second. But first, let's take a look at what's happening graphically here. I want to show you what we're doing. We're trying to figure out how much firm 1 should produce and how much firm 2 should produce. Let's graph this space where we have Q1 and Q2, and let's graph these best response functions. So for firm 2, because I've put Q2 on the vertical axis and firm 2's best response function is already solved for Q2, I can go ahead and graph that. That thing has an intercept of 27, and it has a slope down here of -1/2, so it comes right down like this. That's firm 2's best response function. Firm 2's best response. Here's how to interpret it. Whatever quantity firm 1 chooses, we plug that into the best response function, and out of that gives us what firm 2 should produce in order to maximize their profit. If firm 2 were to produce, if firm 1 were to produce 0 units, then firm 2 should produce 27 units. If firm 1 were to produce some number of units out here, we plug that in, and we see that firm 2 should produce something less than 27. To graph firm 1's best response function, we have to invert it. It's solved for Q1. Let's write it here. Q1 is equal to 27 minus Q2 over 2. I need to solve that thing for Q2. So I'm going to move this over. I get Q2 over 2 is equal to 27 minus Q1. And multiply by 2. Q2 is equal to 54 minus 2Q1. Now I've got firm 1's best response function inverted and solved for Q2, which I have to do to graph it in this space because Q2 is on my vertical axis. It has an intercept of 54 and a slope of -2. It comes right down here like this. By the time it has gone down, for each unit it goes down, so it's got to go down 2 units for every 1 unit it goes over. So by the time it's gone down 54, it's gone over 27. So you should recognize that here's what that looks like. So there's firm 1's best response function. What we did when we essentially what we're doing here is we're setting them equal to each other. We're doing the same thing as if we had a demand curve and a supply curve, where we have 2 equations and 2 unknowns. In that case, we've got price and quantity, and we're solving for both of those. In this case, we've got Q1 and Q2, 2 functions. We plugged one into the other. What we did, though, is we're finding this intersection, and we found that that intersection occurs when each of them produce 18 units. When firm 1 is producing 18 units, firm 2's best response is to also produce 18 units. And when firm 2 is producing 18 units, firm 1's best response is to produce 18 units. That's a Nash equilibrium. Okay? That's the likely outcome for this game. So point A, let's call it, is a Nash equilibrium. Let's think for a second about what would happen if we were at something other than the Nash equilibrium. Let's think about what we would expect to happen if, say, firm 1 was producing 27 units. So suppose we started right here. Let's do this in a little bit different color. So suppose firm 1 was producing 27 units. Well, what that means is that firm 2's best response is to produce this quantity right there. Well, if firm 2 is producing this quantity right here, then firm 1's best response is to produce that quantity. But if firm 1 is producing that quantity, firm 2's best response is to produce this quantity. And you can see that these reaction functions lead us right back to point A, regardless of where you start on this picture. If you were to pick any point up here or any point down here and then see how each firm would react to that firm, to what the other firm is doing, you'll see that their reactions will lead them right back to point A. Point A is what we would call a stable equilibrium. Okay? Any deviation from that equilibrium and the best response functions would move us right back to point A. Let's talk about how to get these. So if you're thinking, oh gosh, this model that we've just gone through, this Cournot competition, seems mathematically challenging. Let me give you the kind of secret that will get you through any problem that I would give you. If you've got an inverse demand curve that looks like this, P equals A minus B times Q. And you've got a nice simple marginal cost curve. Marginal cost is just equal to some number C. So in our example, A was 300, B was 5, and C is 30, wherever that was. I don't know that I've still got it on the board anywhere. But our marginal cost was constant at 30. Then here's what the reaction functions or the best response functions look like. Q1 will be A minus C divided by 2B minus Q2 over 2. Firm 2's best response function will be A minus C over 2B minus Q1 over 2. So as soon as you see the inverse demand curve, and you see the marginal cost curve. In any problem I give you, it will be a nice simple inverse demand curve and a constant marginal cost curve. You can immediately form the reaction functions just by using this formula. A minus C divided by 2B minus the other quantity divided by 2. And you should verify with the numbers we used in this problem that that works for what we did right here. But as soon as I give you a problem where you've got the inverse demand curve and the marginal cost curve, then you can immediately form the reaction functions and go through this process right here, which is not hard. You just have to be careful with your algebra. So solving for Q1 and Q2 shouldn't be mathematically very challenging as long as you remember this. Okay? Let's talk about how these markets compare. Comparison. So we started with Bertrand competition. And with Bertrand, what we saw was that's the same as perfect competition. Same as perfect competition. We talked about collusion. I'm going to put it down here. I'm going to leave a space because we're going to put Cournot in there. So we talked about collusion. Collusion is the same as monopoly. And then we've talked about Cournot, competition. And not surprisingly, Cournot falls in between the two. Falls in between the perfect competition outcome and monopoly. Falls in between. If we were to think about having a Cournot competition model with more than two firms, we just did two firms. Any problem I would give you, there would only be two firms. But if we were to add a third firm or a fourth firm or a fifth firm, then the outcome moves farther away from monopoly, closer to the perfect competition outcome. Okay? So changing the number of firms, increasing the number of firms, not surprisingly, moves us farther away from monopoly. What we're going to do now is finish up this video. In the next video, we're going to talk about some more models of oligopoly. So I'll see you in that video.